Hello, your chemistry tutor is here again to uh, bring out the integrated rate law for zero order reaction. Let's go straight to the point. I am Akpeji Honesty, your chemistry tutor. Okay, so wherever you are watching this video all over the world, I send greetings and I want to encourage you to keep watching, subscribe to my YouTube channel, and share to others. So let's go straight to point to work. Zero order reaction. When you have a reaction, when you have a rate law like this, where the concentration of the product does not actually depend on the reactant. Okay, in this case you have R is equal to K a raised to power 0, which is equal to R is equal to K. So actually it may be a reaction like this, okay, but it's a zero that the product is independent of the concentration of the reactant. That is what is happening here. So it is a zero order. Here rate does not vary with the increase or decrease in the concentration of the reactant. Thus, the rate of this reaction is always equal to the rate constant, okay, of the specific reaction. The product of the reaction is independent on the concentration of the reactant, okay. In short, there are sometimes questions are asked, and inside the question they would have put, it may be a question that require a table. They have given you the table of values, but they have already included, there is a clause there that states that the product of the reaction is independent on the concentration of the reactant. They will now start asking question, Homer figure 1, what is the order of reaction? And they give you table of values. Some will go doing unnecessary calculation. The answer is actually in the question, okay. It is in that case it is actually a zero order, because the product of the reaction does not depend on the concentration of the reactant. Okay, so let's go to the integrated rate law for zero order. In that case, if this is considered as zero order, you have rate is equal to rate law. What is our rate now? We have concentration of A over dt is equal to what? Ka is to power 0. Okay, so in this case you shall be having is equal to K. This is what equals to K. So by the time you cross multiply, you'll be having minus D concentration of A is equal to what now? K dt. Okay, that actually means that you'll be having the concentration of A is equal to what? Minus K dt. Okay, it is at this point you integrate both sides. So when you integrate both sides of the equation, you will be having something like this, okay. Is equal to the negative t at a particular t, and when t is 0, K dt. Okay, so with that, that will give birth to concentration of A is equal to concentration of A naught minus KT. This is the integrated rate law for zero order. This is integrated rate law for zero order. Okay, so let me quickly run through the half-life. So in the half-life of zero order, okay, let me bring back the integrated rate law. This, I am going to be managing this space. I hope you can see what I am writing. Please, if my video is not clear, put it in the comment section. I will be working on that, but for now this is what we can be managing with. Okay, So let my A, okay, becomes A over 2, and my T equals to T half. Let's take these two equations. If this is equation 1, this is equation 2. Okay, so I am substituting equation 2 into 1. I'll be having, in place of this, I'll be putting this, okay, where I'm going to, in place of this, I have A over 2 is equal to my AO remains, this is AO naught, my AO remains minus KT half. Okay, so that means this will actually, okay, you are going to be having KT half, KT half is equal to 1 over 2 A naught. Do you understand that? If you solve it out, that is what you will have. If you don't understand, look at what I mean. Here will come here. Yeah? It will become minus. There will now be A naught over 2 minus A naught over 1. If you solve that out, you will be having, I want to manage this space. Please kindly look at it. If you put A naught over 2 minus A naught, you are going to be having equal to minus KT half. So if you solve A naught over 2 minus A naught, you'll be having A naught minus 2 A naught over 2 is equal to minus KT half. That is what you will be having. And you know, if you factorize it out, you have A naught into bracket 1 minus what? 2, okay, over what? Over 2. And then 1 minus 2 will give you minus 1. So in a nutshell, everything here will give you minus A naught over 2 is equal to this. In a nutshell, you are going to be having minus A naught over 2 is equal to minus KT half. This will go out so that you can be having KT half is equal to 1 over 2 A naught. That is what comes here. Please try it just the way I've explained, you will get it, okay? So if you make T half the surrogate of the formula, you will be having, if you make T half the surrogate of the formula, K will be dividing here. That means you are dividing both sides by K, and when you divide both sides by K and you solve, you'll be having 1 over 2K, then A naught, A naught, or A naught over 2K, whichever. This gives you the half-life for a zero order reaction. I hope you understand that. So, example of a zero order can be found in the photolysis of hydrogen plus chlorine. If you use a UV light, okay, to give you HCl, it's a zero order reaction. And then also 2N2O in the presence of platinum catalyst, hot platinum catalyst, you'll be having 2N2 plus O2. Remember, you don't judge this by the stoichiometric coefficient as the order of reaction. Okay, rate law is experimentally determined. I hope you understand that. Okay, so this explains the integrated differential and integrated rate law for zero order reaction. Here, this integrated rate law for a zero order, this can be T at the time T. Why this is the half-life for zero order. It's quite different from the integrated rate law for first order. You can watch my video on that. And also this is different from the half-life of second that you can equally watch my video on that. Okay, I will be making a video on pseudo first order reaction. We have another of reaction called pseudo first, like a false first order reaction. Okay, just for your own awareness. I want to believe you quite understand what I have done here, and then show it by putting your observation, your comments in the comment section, and also ensure you share this video to others. Thank you and God bless.